Using square roots to solve quadratic equations. So when we're determining a square root, you first have to isolate your x term, take the root of each side, and then verify the solution. And keep in mind that when you take the root of a number, it'll be plus or minus that number. So if we take our first question, x squared equals 16, we have an x squared and it is isolated. We're going to take the square root of both sides. So x is going to equal plus or minus the square root of 16, which is 4. So x could either equal 4 or x could equal negative 4. For the second question, we have to isolate our variables, so subtract minus 5 from both sides. So we have 14 minus 5 is 9. Take the square root of both sides, so x will be equal to plus or minus the square root of 9, which is 3. So x equals 3 or x equals negative 3. The reason why we can have both the plus and the minus is because when you square a number, it doesn't matter if it's positive or negative, your answer is going to be square. So if you take 3 squared, it would be 9. And if you took negative 3 squared, it would be 9. So there's two possible situations where it could work. For our next question, we're going to isolate our variables, so plus 8 to both sides. So we have 2x squared equals 24. Divide both sides by 2, so x squared is equal to 12. Take the square root of both sides, so x is equal to plus or minus root 12. And you can just leave it as a radical. So x is equal to the root of 12 or the negative root of 12. Now, sometimes in the textbook it simplifies the radical. So the simplified form of the root of 12 is 2 root 3. And if you don't simplify it, that's okay for right now. You can just leave it as the root of 12, or you can simplify it to 2 root 3. And for that last example, we have our variables already isolated because it's in the brackets, so we're going to take the square root of both sides. So x, that looks terrible, x minus 1 equals plus or minus the root of 5. So we're going to add 1 to both sides. So x is equal to 1 plus or minus the root of 5. So x could be equal to 1 plus root 5, or x could be equal to 1 minus root 5. And just leave it as a radical. If we take the following equation, 3x squared minus 7 equals 8, our first step is going to be to isolate the variables, so we're going to add 7 to both sides. So we get 3x squared is equal to 15. Divide by 3, and x squared is equal to 5. We take the square root of both sides, so x is equal to plus or minus root of 5. Now, it's good to practice to test both the root 5 and the negative root 5. So you can either type that into your calculator or answer it out. I'm going to show you how to answer it out. So we have 3 times root 5 squared minus 7 equals 8. Root 5 squared is 5. So 3 times 5 minus 7 equals 8. 15 minus 7 equals 8. 8 equals 8. This works. And if you do it with a negative, negative root 5 times negative root 5 is 5. So we get the same answer. So both of these solutions work. For the next example, we're going to square both sides. So we have x plus 3 is equal to plus or minus the square root of 20. Subtract 3 from both sides. So x is equal to negative 3 plus or minus the root of 20. Now we're going to verify. So if we put it into our brackets, minus 3 plus 20 plus 3 squared equals 20. Negative 3 plus 3 is 0, so root 20 squared equals 20, which is correct. And if we do it with the negative, negative 3 minus root 20 plus 3 squared equals 20, we get negative root 20 squared equals 20, and negative root 20 times negative root 20 is 20. So both solutions work. So x equals negative 3 plus root 20 or negative 3 minus root 20. For the next example, we're going to isolate our x. So we have minus 12, so 3x squared equals negative 12 divided by 3 is negative 4. So we have x squared equals negative 4. Now, if you try to take a square root of both sides, you can't ever take the square root of a negative number. You can't do it. So if you come to a solution where you have the square root of a negative number like this, your answer is you have no real roots. There's no real roots that can solve this equation. So there's no real roots. Okay, completing the square is a way of determining your roots. It requires you to know how to factor a perfect square trinomial. So if we remembered ax squared plus bx plus c, if my a was a square and my c was a square, then 2 times the root of a times the root of c would equal my b. So the square root of c times the square root of a times 2 would equal b. What we're going to need to figure out is our b. We want to know what our b is to help find our c. That didn't make sense. We want to know c. So we want to isolate our c variable. So we're going to divide by 2 times the root of a. So root c is equal to b over 2 root a. And when we do this, we're always going to have a equal to 1. So it's going to be just 2 times 1. And to get c by itself, we square both sides. So c is always going to be equal to b over 2 squared. That's just something you need to remember. This formula right here. So when we're completing the square, we are going to isolate our x and our x squared and our x, all of our x terms. So we need to move this 3. So we're going to add 3 to both sides. So x squared plus 4x is equal to 3. Now, we want to turn this into a perfect square trinomial. So we have to figure out what our c would be if it was a perfect square trinomial. So we're going to use the formula c equals b, which is 4, divided by 2 squared. So 4 divided by 2 is 2, so 2 squared is 4. So we want to add this 4 as a constant. So we're going to add 4 to both sides. So we get x squared plus 4x plus 4 equals 7. Now this on the left side is a perfect square trinomial. So we know that when it's a perfect square, all we have to do is take the square root of our first term plus the square root of our last term. So we get x plus 2 squared equals 7. Now we have a solution that we can solve. So we're going to take the square root of both sides. So x plus 2 equals plus or minus the square root of 7. Subtract 2 from both sides, so x equals negative 2 plus or minus the root of 7. So our two answers are x equals negative 2 plus root 7, or x equals negative 2 minus root 7. And that's our solution. So if we take our next example, x squared plus 14x minus 2, we want to add 2 to both sides to get x squared plus 14x equals 2. We want to find our c value, so we take our b divided by 2 squared So c equals 7 squared, which is 49. So we're going to add 49 as our constant, so x squared plus 14x plus 49 equals 2 plus 49. We know that this is a perfect square, so we get x plus 7 squared equals 51. Take the square root of both sides, and x plus 7 equals the root plus or minus of 51, minus 7 from both sides, so x is equal to negative 7 plus or minus the root of 51. Therefore, x is equal to negative 7 plus root 51, or x is equal to negative 7 minus root 51.